Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to supply you with another example of applying Newton's laws of motion effectively. So in this example, we have a 100-pound object suspended by the pulley system shown. Let's see, find the weight needed for the system to be static. That's referring to this one. Okay, assuming the pulleys are in good working order. I'm also going to add assuming the pulleys are light too. I probably should have put that in there. So an important thing to realize, a pulley, all it does is change force directions. Okay, so when we look at this rope right here, this is all one rope or string or whatever to this point right here. And what that means is whatever the tension is here, it's the same here, 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 really anywhere. Okay. Now, when you draw free body diagrams, you want to be very clear about how you define your system. And what I'm going to do here is define our system like this. Now, you also don't want to use your original picture for your free bodies. Things get too muddled here. What you want to do is, I'm going to come over here and just draw a quick sketch of the system. And now I'm going to start putting force vectors in. That object weighs 100 pounds, so I could represent that with a single force vector pointing down, 100 pounds. Now, the tension in that rope, you'll notice it crosses that surface here and here. So effectively, there's two of them. This rope we don't need to worry about because of the way I define my system. That's referred to as an internal force. Even if I include a tension for that force, it is up at this location and down at this location. It adds to zero anyway. All right. And now we'll go ahead and draw a free body, or I'm sorry, we already did that. Now we'll go ahead and write a Newton's second law equation for our free body. So Newton's second law says, all right, the net force, which is the vector sum of all forces acting, equals mass times acceleration. I'm going to go ahead and do this with up positive. You could also do down positive. It's not going to make any difference at all. Now, in this example, it's static. That means that it's not moving and it's not accelerating. So this has to numerically be 0 in this example. Now, when we look at our free body, there's an upward tension, another upward tension. The 100 pounds is down, and that's it. So this sum is equal to 0. And it's not too big a surprise here. It's not too terrible in math here to solve this for t, and you'll end up with 50 pounds. So there is an example of how to draw a free body diagram to analyze a simple static system. I hope that this helped. Have a great day.